All right, let's dive into one of the most fascinating and honestly mind-bending ideas in all of cryptography, zero-knowledge proofs. We're going to demystify how you can prove a secret without ever giving the secret away. So let's kick things off with a question that just sounds, well, impossible, right? How can you possibly prove you know something, like a password, without actually showing the password itself? It feels like a paradox, but figuring this out is absolutely key to our digital future. But before we get into the really cool techie stuff, let's talk about the problem this all solves. It's something we deal with every single day online, this constant trade-off between getting to use a service and having to give up our private data. It's a real balancing act. And this right here, this is the perfect example. Think about proving you're old enough to buy something. The old way, on the left, means you show your entire driver's license. And just like that, you've also shared your name, your address, your exact birthday, tons of extra info. But look at the ZKP way on the right. You get a simple true or false. That's it. Nothing else is revealed. It's the difference between using a surgical scalpel and a sledgehammer. And yeah, that's really the core of the whole thing. It's super easy to prove you know a secret by just telling everyone the secret. The hard part, the real magic, is proving you know it without the big reveal. So how in the world is this trick actually done? Okay, so how on earth does this cryptographic magic actually work? Well, we're not going to start with a bunch of crazy math. Instead, let's begin with a really simple and pretty clever analogy that just involves two colored balls. This classic analogy really nails the concept. So your friend is colorblind and they keep challenging you. Did I swap the balls? See, every single time you get it right, it's another piece of evidence. You're building up this mountain of proof. After you do this over and over, the odds that you're just guessing become astronomically small. Your friend becomes totally convinced you know the secret, that you can tell the colors apart. But here's the kicker. They never learn which ball is red and which is green. That's the zero knowledge part in action. Okay, so let's take that simple idea with the colored balls and put it into its official techie definition. A zero-knowledge proof, or ZKP, is just a method where one person, the prover, convinces another person, the verifier, that something is true, but without giving away any extra information at all. The only thing the verifier walks away with is knowing, yep, that statement is true. Now, this is super important. For ZKP to actually be secure, it has to have these three core properties. Completeness just means that if you're telling the truth, the proof will work. Soundness means a liar can't fool the system. And zero knowledge means the proof itself stays a complete secret. You need all three, no exceptions. And you know what? This isn't just some abstract idea from a textbook. ZKPs are actually out there, in the wild, being used to solve some really big real-world problems. So let's take a look at where this is all happening. So probably the biggest and most famous place you'll see ZKPs in action right now is in the world of cryptocurrency. You know, blockchains like Bitcoin are famously transparent. Everybody can see everything. ZKPs are the technology that lets us add a much-needed layer of privacy on top of that. Zcash is the classic example here. It uses a specific flavor of ZKP called a zk-SNARK. And what this does is let someone prove they have the money to spend and that they're allowed to spend it, all without revealing who they are, who they're sending it to, or even how much they're sending. It's like putting a privacy shield around your transactions on a public network. But it's not just about money. Another absolutely huge area for ZKPs is our digital identity. I mean, think about it. How many times a day do you have to prove who you are online? ZKPs are on track to completely change how we do that. And this is a complete game changer, really. Right now, we trust giant companies to hold all our sensitive data on their servers, which, makes them a massive target for hackers. ZKPs flip that model on its head. You control your own identity and can just prove little facts about it, like I'm a citizen or I'm an employee, without ever showing your passport or ID card. Suddenly, that giant vulnerable honeypot of data just disappears. And this tech isn't just for the digital world of bits and bytes. It can actually bring more trust and security to the physical world, like in incredibly complex global supply chains. So get this. Imagine you've got two companies that are fierce competitors, but they have to work together in a supply chain. One of them can use a ZKP to prove to the other that their product is, say, 100% organic without ever having to reveal their secret formula or business process. It lets them cooperate and prove things to each other while still protecting their trade secrets. It's pretty amazing. All right, so what's next? The potential here is just massive. There's no doubt about it. But like any powerful new tech, we still got some real hurdles to clear before ZKPs are everywhere. And the tech itself is evolving like crazy. This table gives you a peek into a big debate in the ZKP world, SNARKs versus STARKs. It's all about trade-offs. SNARKs give you these tiny, super efficient proofs, but they need this trusted setup phase, which is complicated and has to be done perfectly. STARKs, on the other hand, don't need that, which makes them more transparent. Plus, they're built to resist quantum computers in the future. The downside? Their proofs are a lot bigger. The whole field is racing to find that perfect sweet spot between security, size, and trust. You can see right here the main hurdles we're facing. The biggest one is just how complex this stuff is. The math is intense. That means there aren't a lot of developers who can actually build with it yet. And on top of that, it takes some serious computing power to create these proofs, which can make things slow and expensive. These are tough engineering problems, but they are being worked on. But even with those hurdles, there's a strong consensus that zero-knowledge proofs are a foundational building block for what many people call Web3, the next version of the internet. They are the ingredient that brings real, verifiable trust to a decentralized, user-first online world. And that really brings us to the big, mind-bending question this technology leaves us with. It's not just about better security. It's a tool that could completely change our relationship with technology itself. So we have to ask, if we could build an internet on provable facts instead of just blind trust, what would that world actually look like?